All right, Unit 4, we actually start getting into the more trigonometry part of the class that is called Trigonometry and Precalculus. So, with trigonometry, we got to start off talking about angles. We're focusing today on radians and degrees. So, our objectives for today, we're going to understand the difference between radians, or a radian and an angle measure. We're going to determine coterminal angles, and we're also going to convert from radians to degrees and vice versa. So, just starting off with the definition, an angle is determined by rotating a ray, which remember is half a line, so it's pointing in only one direction, about its endpoint. We'll call it the vertex. In this space below, let's draw an example. So here's an example of an angle, and we're going to have a couple different sides to it. So the bottom side, I'm going to call that the initial side. I'm still in shape mode, sorry. Initial side. And the end side we're going to call the terminal side. Sorry, writing at an angle is not working super well for me right now. Terminal, there we go. And then we're going to call this point here A, and we're going to call this angle measure here theta. And again, we'll call this angle A, and that kind of like looks kind of like a less than sign, but the bottom part is more horizontal. That's the angle measure. So, a couple different things. A positive angle. Positive angles are generated by rotating it counterclockwise. So going the opposite of a manual clock. A negative angle. So negative angles you do a clockwise rotation. So as you see in figure 4.3. So again, counterclockwise is kind of like up and to the left, and it's down and to the left for negative angles. For radians and degrees, let me zoom in on that. 1 radian is the measure of a central angle theta that intercepts an arc S at or equal in length, goodness gracious, to the radius r of the circle. So, example, here's this measure here. If this is the radius r, this length of this arc right here is also measure r. That's how a radian is defined. Now to calculate radians, we're going to do theta, the angle measure in radians, is s divided by r. So the length of that arc divided by the radius. And again, we're measuring that in radians. So a couple of key things down here. The biggest pattern you'll notice in radians is, that was a horrible sentence. Let me start that over. The most common radian measures you'll see end up being something over 6, over 4, over 3, or over 2. So we have pi over 6, pi over 4, pi over 3. So pi over 6 is just that small sliver, pi over 4 is a little bigger, pi over 3 even bigger, then pi over 2. You'll notice there's also a 90-degree measure there. We'll talk more about that reference later. Then if we were to go half of the circle around, that's pi radians. And if you go all the way around the circle, that's 2 pi radians. Also of note, our quadrants. In quadrant 1, our angle measures are between 0 and pi over 2. In quadrant 2, so the upper left there, it's between pi over 2 and pi. So once we get to here, that's reached pi. For quadrant 3, it's between pi and 3 pi over 2. And for quadrant 4, it's between 3 pi over 2 and the full circle at 2 pi. Let's take a little bit of a look at an example here. Or, sorry, I'm getting ahead of myself. Coterminal angles. Angles that have the same initial side and the same terminal side. So they're coterminal. They share a terminal. The biggest thing you can do to find coterminal angles is add and subtract multiples of 2 pi, a full circle. Or if we're talking about in degrees, which we'll get back to degrees in a second, 360 degrees. So we're adding and subtracting multiples of the full circle. So pi over 6, that's just that small little sliver we looked at on the previous page, maybe about yay big. That's not perfect, but the reason we know it's pi over 6 is because we labeled it as pi over 6. So to figure out coterminal angles, I'm going to take pi over 6, and I'm going to add 2 pi to it. Since we're already in radians, let's just keep it in radians. So to do that, I'm going to have to convert 2 pi into something over 6. I'm going to make it pi over 6 plus 12 pi over 6, which gives us 13 pi over 6. So that would be as if we were to start on the same terminal or same initial side and go a full circle and then back to there. So it's like we do 2 pi plus another pi over 6. Now we can also subtract 2 pi. So if we do pi over 6 minus 2 pi, it's going to be the same setup as the previous one, but instead of adding 2 pi over 6, we're going to subtract adding 12 pi over 6, we're going to subtract 12 pi over 6. So pi over 6 minus 12 pi over 6 gives us negative 11 pi over 6. And again, that would be starting on the initial side, working our way backwards that way. So not quite a full circle in the backwards direction.